welcome to Building Performance Talk. I'm Leslie Jackson. Today our guest is Chris Magwood of the Endeavour Centre in Ontario, Canada. He spells Endeavour Centre the Canadian way, so I'll list that in the show notes. Back in the day when we first met, we were both natural builders. He had published this book with a new society called Straw Bale Details in 2001. I worked on crews that used this book on the job site. So it was really fun to run into him at the Getting to Zero Forum in October 2019, feels like 100 years ago, in downtown Oakland. His presentation included a project performed by Endeavour Center and the Ryerson University staff and students to build prefab stackable row houses and deliver them to the site, build them in a day, disassemble, reassemble, disassemble again. Beautiful work. You'll get to see that in this show. I asked him to come on and unpack for us some of the terms around embodied carbon. Chris, welcome to Building Performance Talk. It's great to have you with us, and it's great to see you again after just seeing you in October at the Getting to Zero conference in Oakland, California.
Yeah, I'm really glad that we could be doing this.
Good. Why don't you tell us a little bit about who you are and what Endeavour Center does?
My name's Chris Magwood, and Endeavour Center is we're a not-for-profit sustainable building school up here in snowy Peterborough, Ontario, Canada. So we do a bunch of things with Endeavour. The main thing we do is we run a full-time certificate program for students who basically build a building with us from start to finish. So they get a chance to see, we kind of have in our core values, we do buildings that have a zero carbon footprint, contain zero toxins, and to the best degree we can generate zero waste. And so the way we go about achieving that from year to year is kind of different depending on the client and the building, but the class basically gets to see, what it takes to do a building that meets those kind of goals.
How exciting. I wanted that school in 2003. I sort of
So did I,
envisioned
and
doing that.
that's why we did it.
Great. There's nothing
Yeah.
like hands-on and the kinds of bright minds and the ideas that they bring.
Yeah.
Such a treat to work with. Great. And your presentation at the Getting to Zero Forum, is that a typical show for you? Is that something that Endeavour Center devotes some time to, the thinking about embodied carbon?
It is, and that presentation I've been making lately, it's developed a lot. So Endeavour for our whole sort of 10 years has been thinking about climate change and how buildings impact it. But it's really in the last sort of 3 or 4 years that I really got sort of interested in looking at the materials side rather than the operational side. Kind of embarked on a bunch of, I would call it citizen science studies on our buildings to see if I could sketch out what the carbon footprint of all the materials we use. I kind of got some answers that made me wonder if I was doing it the right way. And so I kept kind of going deeper and deeper. Eventually I decided to go do a master's degree and do it for real. So, the presentation you saw was coming out the other side of that master's degree and feeling like, wow, I'm sitting on this treasure trove of data that very few people have sort of looked at, and that gives this really surprising result that, really the emissions from the materials we're putting into buildings outweighs the operational emissions for anywhere from 10 years to 50 years. And so it turns out that if you want to really address climate change with buildings, you absolutely have to really look at the materials carefully, because you won't. One of my colleagues has this saying, we can't net zero energy our way out of this. Like, you can make these crazy efficient buildings thinking you're doing the right thing for climate change, but you could actually be causing more climate change by using materials that, even though you hoped you were, by making the building more energy efficient.
Right. Which doesn't mean don't make some efforts towards energy efficiency in
Oh,
the
absolutely. Like,
operation of the
I try
buildings.
to, in all my talks, be very clear. I'm not talking people out of energy efficiency.
Mm-hmm.
That's super important too, but it has to be part of a sort of coordinated effort, and that you can be really conscious about deciding what target you want to hit. And then you have to look at the material side and the operational side to actually hit that target. You have to be very conscious of both things. And, to date, most of the building industry has kind of ignored the upfront piece altogether. And so I'm just trying to bring that into the equation, but it's very much an equation. It's not, oh, now you should only look at materials that, forget this other side, because, we really won't bring building, emissions down to zero like we need to on one side or the other. It's going to have to be both.
So it isn't a competition between operational energy and the embodied energy of the materials, but a three-legged race in which both are in the same sack.
Absolutely. And I like that weird mixed metaphor.
Thank you. All right, let's run through some terms. And if you think of any at the end or in between that you want to throw in at me, please do so. Environmental Product Declaration? What's that?
Yeah, people refer to them as EPDs, but an environmental product declaration is a document that a company, a manufacturing company, can have made. So they hire a third party to basically come and look at their operations. So if I'm a manufacturer of some kind of building material or component, somebody reviews my whole operation from the extraction of the raw materials that I'm going to use. And if there's multiples of those, they look at all of them, how they get to my facility, what inputs and energy and emissions are associated with what I do in my facility. And then sometimes it stops there, or sometimes they sort of keep tracing the emissions all the way through use of the product and disposal of the product at sort of end of life.
Right.
So people call it a nutrition label for buildings. And one of the pieces of information on that nutrition label is the global warming potential of that particular product. And so in my study, and as other people are sort of looking at the material side of things, that's where we're getting that information from an environmental product declaration. So it's sort of publicly accessible documents that companies are putting out that sort of attribute a certain amount of emissions to a certain amount of their product. So a kilogram of drywall has X number of kilograms of greenhouse gas emissions associated with it. And so, somebody like me wanting to research this can go find these EPDs and scrape that data out of them and see how much of that material I'm putting in my building and apply that global warming factor to it, and sort of get a sense of, what is the carbon footprint of that particular building.
Then you're talking about real terms. Then you're talking about numbers you can look at, measure.
Yeah, and the EPDs are done according to an international set of rules that everybody kind of follows. So that means that the person assessing those products has to do it in a certain way and declare certain assumptions. And so it gives you a pretty, people will say, oh, they're not perfect numbers, but numbers rarely are. But, it gives you a good sense of comparison. You can really tell between either different product types that have the same function in a building, or different product, the same product, but from different manufacturers. You can get a sense of, okay, I'm better using this type of material, or if there's enough data, oh, this one from this particular manufacturer is, has the lowest carbon footprint. So,
okay.
And hopefully someday, that'll just be, that label should just be on the product. You go to your building supply store and there it is. It's on the front of the package, and you can kind of see that up front. Right now you have to be a bit of a nerd like me and go to the company's website and find it and pull the data out yourself and do your own calculations. But, hopefully it will just sort of be something that's up front and everybody sees soon.
Embodied carbon.
Yeah, and embodied carbon, I think, is the worst name for this thing that we're talking about. I find it to be a very misleading or sort of not intuitive term, because to me, embodied carbon would be the carbon that's contained in the thing we're talking about. What it's actually come to mean is the carbon associated with that thing. So if I'm talking, say, drywall, it's when they were mining the gypsum, how much emissions came out of the backhoes and the trucks and the equipment in the mine, and does anything come out of the rock or out of the earth that goes into the atmosphere.
Sure.
And then some trucks drive it to a factory and there's emissions. And then in a factory, they run heaters and they do all of these things and a bunch of emissions happen. So it's actually not
awkward.
Yeah, it's not the carbon embodied in the material. It's the
associated carbon,
emissions.
right?
Yeah, so I try to call it upfront carbon emissions.
Okay, but what are you, sorry to interrupt you, but what are you doing to the rest of us? Should we start using the word upfront carbon? Or do you use that sort of interchangeably so that that's more sort of literal for your listeners?
Yeah, I think, the tricky part is now the researchers who've been looking at this for the last decade have invested in that term embodied carbon, and it's become the language that the people in the world know and use and talk about. But I think it's not the best term, and I think it would make bringing it more out into the public easier if we weren't using that term. But once a whole like micro industry has a term that they flip out easily, and it's become the search term you use in Google and all of that kind of stuff, it's hard to stop that train. Then some of what I'm looking at is there are some materials that literally do have carbon embodied in them, which is a good thing. And actually, the more carbon that's literally stored in a material, the lower the embodied carbon number is. So it gets very counterintuitive and a bit confusing to
supply chain.
Okay, that would be the sort of all the pieces that come together to make one material that you're going to use in a building. So, to lean on the drywall example again, the supply chain includes, a gypsum mine, a source of paper, a source of glue for that paper, and all the sort of ingredients that basically a drywall company assembles into the product that I would put in a building. Mm-hmm. So the supply chain kind of traces all of that back, and sometimes it's really straightforward, and sometimes it's almost impossible to trace. Where did this 1% of this chemical that's going in here come from? Well, it came from a chemical company that actually got one of the ingredients from here and another one from there. And so sometimes it's very hard to trace, and sometimes it's as straightforward as, oh, there's a tree in my backyard, I cut it down and I sawed it up and I put it in my building. That's a short and direct supply chain
with a pruning saw.
Yeah.
Okay, how about what about net zero building? Do you use that term in your work?
Yes, I do, but it doesn't mean what most people think it means. And I think it's a term that is, because it's in wider circulation, maybe even more misleading than the embodied carbon thing, because there's a very big difference. Net zero has come to mean net zero energy. It's kind of the short form for a building, a net zero energy building. And a net zero energy building means that you're producing as much energy on site as you're using on a sort of annual basis. But what net zero energy doesn't take into account is that the actual climate change implications don't show up in that metric. So in other words, if I can burn the equivalent of 100 kilowatt hours of natural gas in my building, and my solar panels make 100 kilowatts of power in the year, that's a net zero energy building. But from a climate perspective, that natural gas went into the atmosphere as carbon, and the solar panels didn't remove that carbon from the atmosphere. So the net zero energy building is not necessarily a net zero carbon building.
And we're really talking about a net zero building operation.
That's right. And that's right. And we're not talking at all about the materials. So to me, a net zero building is one that there is zero emissions from the materials, and then there are zero emissions from the operational. That's a real net zero building, right? And from the climate's point of view, that's zero. And to talk about net zero energy is a bit of a numbers game, and the climate doesn't really care.
Right. Do you then need a new term for your use of the word net zero? building?
I mean, you could just say net zero carbon instead of net zero energy. I guess that would,
Mm-hmm.
steer people to what metric we're actually talking about.
Right.
Yeah.
Tell me about EC3. What is that tool, and is that sort of the defining tool that everyone uses?
I think it's probably on its way to becoming that. So it's the EC3 is the Embodied Carbon in Construction Calculator, and it's a project from the Carbon Leadership Forum and a whole whack of really great sort of sponsors and people who've put time into it. But it's essentially taking all the information from the environmental product declarations that we talked about earlier, and it's putting it all in a free open source database, so that when I did my research, I had to go hunt down all of these EPDs on company websites and in various places, and
Did the
it was sort of like secret hockey card trading for a while. And
you
so
did your
what
paid your
EC3 is
dues.
doing is kind of pulling that all up into the public. It's it doesn't have all of them right now, but it's on its way to becoming that sort of repository where, okay, if I want to know this information, there's a place to go get it. They're doing really great things with it. They're making it accessible. They're making it so you can sometimes plug your architectural model for a building in, and the amount of materials you're using will kind of like get pulled right out of your model. And so just really great, it's a really great tool. And within, I'm sure, a few years, it will be, a complete game changer in terms of, how much we have access to that data.
So what I mentioned the Ryerson University study just briefly, and then I'm wondering where you can send our viewers to catch up on that story, which is pretty remarkable.
Sure. Yeah. So that's a project that we did with our Endeavour class in 2017. And all of our projects are on our endeavourcenter.org website. There's little slideshows of all of them there. But the Ryerson one was cool because we wanted to take this idea of a carbon storing building, of natural materials, all that kind of stuff, and not just look at it as a, like, how can we make panels out of these, but how can we make panels that you can both put up and take down,
Love it.
so that at the end of a building's life, we don't stop seeing buildings as, oh, we've got to smash all this stuff up and then, take it to a dump or take it to a recycler. It's like, well, why can't we just undo a bunch of bolts and all of these walls are still walls, and they could go together in another form or together again in another place. And we did the roof and the floor in a panelized way too. So we had a
Wow.
building that, we built here in Peterborough and then took down and put up at a design show in Toronto, and then took down and then put up on a client site. And the up and down part only takes a couple of days. So, that same building component now can have a much longer lifespan, because when the person who's living in it now doesn't want it there anymore, it's either movable as a whole building, or you could take those square components and reconfigure them and add some other things to it and have give those components a whole new life.
Incredible.
Yeah.
Great. Right. What could go wrong is one of my favorite questions in talking to anyone about anything. And I wonder, with this kind of measurement of embodied carbon, upfront embodied carbon, excuse
Yeah.
me, what could go wrong?
Well, I think the same thing could go wrong that goes wrong with most things that we tend to tackle in our culture, which is we decide this is what's really important, and we kind of put on these blinkers, and then we only look at that as the metric, and we stop thinking about, is it healthy when it's in the building? What happens at the end of its life? Is it fairly sourced, and did the people who are making it were treated fine? Like, we
Do I
tend
feel
to, in
like
the
I
same
live in a
way,
house?
yeah,
Am I
the same
comfortable?
way that we've done that with energy efficiency
Hmm.
is like, oh, now we have this metric, and we will, absolutely, um, ultimately achieve this one goal and forget about everything else. So
Yeah.
I do sort of, I am a bit worried about that. And the other thing that I hope doesn't go wrong, but could, is that, the best materials from this embodied carbon point of view are plant-based materials,
Hmm.
because in general, they're storing more carbon in the material than was emitted in making it. So they actually kind of on your ledger sheet give you a negative number, so that you actually can end up with a building that's literally storing more carbon than was emitted in making it. So you get to start below the zero line. And one of my concerns is that, product manufacturers will just start to go, oh, if I stick 32% chopped straw content in my styrofoam, I can make a zero, embodied carbon styrofoam, or, whatever the material happens to be. And I really hope that, we don't go down that path where we're sort of making sort of monster materials, but that sure look great from an embodied carbon point of view.
Right. That's a beautiful caution to have.
Yeah.
How do we prevent that?
Pay attention to more metric than one. That's why, early on when I was talking about what we do at Endeavour is, our 3 guiding principles are zero carbon footprint. So that's including materials and energy use, zero toxins, and zero waste. And I feel like, if we pay attention to all 3 of those, we really end up kind of doing the right thing. And we sort of avoid some of those short circuits that can happen if you, just throw a lot of attention into one particular way of looking at things. Sounds
Great,
good.
Chris. So fun to see you. So fun to spend
nice
time
to
with you this way. Thanks. All right. We'll talk to you soon.
Okay. Bye.
Bye. You've been watching an interview with Chris Magwood of the Endeavour Center. Our theme music is by Tim Walker of Bowfunk. Find details of how to subscribe to Building Performance Association's newsletter, how to become a member of the association, and how to stay up to date with the Endeavour Center in the show notes. This is Building Performance Talk. I'm Leslie Jackson.